So here is a question on relative velocity. Here two particles A and B are moving in concentric circles of radius r1 and r2 respectively as shown in the figure here. So here particle A, which is the red color particle in the figure, is moving in a circle of radius r1, and the B colored particle is moving in circle of radius r2. And as you can see here, A is going in anti-clockwise sense and B is going in clockwise sense. And we have to find the relative velocity of these two particles at t is equals to pi by 2 omega. So we have to find VA minus VB, and VA minus VB is the relative velocity of A with respect to B, that we already know. So now let's see how these two particles are moving on these two concentric circles. So this is the motion of these two particles. Now first of all, let's see what will be the location of these two particles at t is equals to pi by 2 omega, and that we can easily calculate by the formula theta is equals to omega into t. So if we calculate theta A, actually for both the particles theta will be same, only the sense will be different because both of them have the same angular velocity and we want their location at the same time. So how much theta will they cover? Theta will be omega into pi by 2 omega. So omega and omega will get cancelled, and we can see that these two particles will cover an angle of pi by 2. So A will reach at this point after covering pi by 2 in anti-clockwise sense, and B will reach here after covering pi by 2 in clockwise sense. And at this moment we want to calculate the relative velocity of A with respect to B. Now first of all, let's write how much is the velocity of A and how much is the velocity of V. So we know that VA can be written as omega A into RA. So here omega is omega only, omega is given as omega here, and R1. Now if I want to write it in vector form, then you can see this particle will go in minus I cap direction. So in vector form, I can write VA as minus omega R1 I cap. And exactly like this, we can write the velocity of particle B. So particle B will also be going in the minus I cap direction. So we can write VB is minus omega R2 I cap. The only difference here is the radius. Omega is same for both the particles, but they are moving in different circles and they have different radius. So now the only thing which is left is to calculate the relative velocity VA minus VB. So we can write VAB is VA minus VB, and we know both of these values, so we can write this as minus omega R1 I cap, this is the velocity of particle A, and minus of minus omega R2 again I cap. So this minus and minus will become plus, and we get omega R2 minus omega R1 and in I cap direction. So this is the relative velocity of A with respect to B. Let's check the options. Here we are getting option D as correct answer for this question. So here is the next question on relative angular velocity. We have been given two particles which are moving with velocities VA and VB as shown in this figure here. You can see here VA is making an angle theta A with the negative x-axis and VB is making an angle theta B with positive x-axis. And we have to find the relative velocity, relative angular velocity of B with respect to A. Now first of all, let's resolve the velocities of these two particles along x and y axis. Here we are taking this as positive x-axis and this as positive y-axis. So when you take the components of velocity of A in the two directions, we get the components like this. So here VA was in this direction and it is making an angle theta A with the negative x-axis. So we get VAX as VA cos of theta A and VY will be VAY will be VA sine of theta A or small. So these are the components of velocity of A. Now let's see the components of velocity of particle B. So here VB is making angle theta B with the positive x-axis. So here we get VB cos of theta B, and in y direction we get VB sine of theta B. So these are the four components of the two velocities of A and B. So if you summarize all of these, we get VAX as VA cos theta A, and y minus because it is in minus x-axis, that's why a negative sign is given here. VAY will be VA sin theta A, and similarly for particle B, VBX is VB cos theta B and VBY is VB sin theta B. Now, in which direction we should find the relative velocity to find the relative angular velocity between these two particles? Whether it's in x direction or in y direction. You can see here in the figure, the line joining these 2 points is along x axis. So we should find the relative velocity in the direction perpendicular to this line. So in the direction perpendicular to this line will be y axis. So we should find the relative velocity in y direction. So here when we subtract the velocities of A and B in y direction, we get the velocity of B with respect to A in y axis as VB sin theta B minus VA sin theta A. And now to find omega, we can use the formula relative velocity by the distance between the 2 points. And from that, we get omega as this value. Now let's check the options. Here you can see option C comes out to be correct for this question. Let's see this question on net forces. Here we have to find the magnitude of minimum value of this force F, which we are applying on this block at an angle 53 degrees from the negative x-axis. So we want to find the minimum value of this F such that the block just starts to go up against the wall. It means we don't have to provide any acceleration to this block. We just want the motion to start. It means we need to use the condition of equilibrium. So let's see the FBD of this block. Here in the FBD you can see, first of all, the weight of this block will act in the downward direction. And since we are trying to move the block in the upward direction, the friction will try to oppose and also act in the downward direction. So here you have mu times n. And now when you take the components of this F along vertical and horizontal direction, we get F cos 53 along minus x-axis and F sin 53 along plus y-axis. Now there will be one normal from the wall also. So here block is applying a force on the wall, so wall will also apply a force on the block in the opposite direction. So this is the normal which is applied by the wall on the block. And now as I said, here we have to use the condition for equilibrium because the block is not accelerating. We just want to start the motion of the block. It means the external F should be able to overcome the other forces which are acting on this wall or on this block. So let's write the equations of motion or Newton's second law equations for x-axis and y-axis for this block. So as we know that this is our x-axis and this is y-axis. So first of all, in x-axis we can write n is equals to F cos 53. There are no other forces acting in x-axis, so n will balance out F cos 53. And in y-axis we have F sin 53 is equals to mg plus mu times n, where mu n is the friction, maximum friction acting on this block. Why maximum friction? Because we are just starting the motion. So limiting value of friction should act here to find the minimum value of capital F. So now we can substitute n from this first equation to the second equation. And when we do that, we get f sine 53 is equals to mg plus mu times f cos 53. And now here in this equation, we know all the variables except capital F. So let's take the terms of f on one side and take all the other variables on the other side. So we'll get f into sine 53 minus mu cos of 53 will be equal to mg. And mg value is given to us in the question, it is 12 Newton. The weight of the block is given to us as 12 Newton. So we get F as 12 upon sine 53. Sine 53, as we know from this triangle of side 3, 4 and 5. So opposite to the side 3, we have the angle 37 degrees. And opposite to the side 4, we have the angle 53 degrees. So sine of 53 will be perpendicular upon hypotenuse, which will be 4 by 5. So that will be 4 by 5 minus mu is given to us here, that is half into 3 by 5. You can see in the triangle cos of 53 comes out to be base upon hypotenuse, which will be 3 by 5 in this particular triangle. And when you simplify this, you get F as 24 Newton. So let's check the options. Here you can see 24 Newton. Option C is correct answer for this question. So here is a question on circular motion. In this question, we have a car which is moving on a circular path with a constant speed of 10 meters per second. So the speed of the car on the circular path is 10 meters per second. And we have to find the magnitude of change in velocity when it moves through an angle of 120 degrees. Now, just try to understand what we are supposed to calculate here. We want change in velocity, magnitude of change in velocity. It means we want to calculate the magnitude of change happened in velocity. Now, I'll tell you what common mistakes which students do here in questions like this. What they think is initial velocity 10 meters per second, and since the velocity or the speed of the car is not changing, the final velocity will also be 10 meters per second. So they just subtract it. 10 minus 10 comes out to be 0. So magnitude of change in velocity is equals to 0. This is completely wrong. Actually, in this, what we have calculated is magnitude of change in speed. Velocity is a vector quantity. So when we want to find the change in velocity, we should consider the direction of velocity also. So after finding the change in velocity, then we have to find the magnitude of that change in velocity. That is the approach which we should follow in questions like this. So let's see how to do this kind of questions. Now here we have a car, and let's suppose it starts from this point A. And to cover 120 degrees, it will reach another point B after covering this angle of 120 degrees. Now here the velocity of this car will be in this direction, which will be tangential to the path. And at B also the velocity will be in this direction, which will again be tangential to the path. So if I want to find the change in velocity or the magnitude of change in velocity, I should use the formula of vectors. So as we know that magnitude of change of two vectors can be calculated by the formula mod of VB minus VA, which will be under root of VB square plus VA square minus 2 VB VA cos of theta. And this cos theta, this theta is the angle between the two vectors. So as I said, initially the velocity will be tangential to the circular path, and finally also the velocity will be tangential. So the angle between these two velocity will be 120 degrees in this case. Because if you draw this circle, let's say initially the particle is at this point. So here the velocity will point in this direction. And after covering 120 degrees, the particle will reach here. So velocity will be in this direction. So if you measure the angle between these two vectors, then it comes out to be 120 degrees. Because if these two radiuses are making an angle of 120 degrees with each other, then their tangents or their perpendiculars will also make the angle of 120 degrees. So the angle between these two velocities is 120 degrees. Now we know the magnitudes of these two velocities, we know the angle between them, so we can substitute here in this formula. So let's do it. Here we have under root of VB square plus VA square. Both can be written as 10 square plus 10 square minus 2 into 10 into 10 into cos of 120. Now here we can take 10 square common from the three terms. So we get 10 outside, and inside we have 1 minus 2 cos of 120. And now here we can use a formula which we have seen in trigonometry. The formula is 1 minus cos theta is equals to 2 sin square theta by 2. So here also we have 1 minus, here this will be 2 minus 2. So when you take 2 common, you will get 1 minus cos of 120. So here we can apply this formula of 1 minus cos theta. So when we apply this, we get 2 sin square 60. And when we substitute all these values, we get 10 root 3. So let's check the options now. Here you can see option B, 10 root 3 is the correct answer for this question. So let's see this question on angular displacements. Here we have three particles A, B and C which are moving in a circle in anti-clockwise direction with speeds 1 meter per second, 2.5 meters per second and 2 meters per second respectively. So the speed of particle A is 1 meters per second, the speed of particle B is 2.5 meters per second and that of C is 2 meters per second. So that is given to us. The initial positions of A, B and C are given to us as you can see in the figure here. And we want to find the ratio of distance travelled by B and C when these three particles meet. Now, initial locations of these three particles are these points A, B and C. So A is located here, B located here and C is here. Now let's say they all meet at this point for the first time. It means B has covered this angle theta B, A has covered this angle theta A and C has covered this angle theta C. Now if the three particles are meeting at this point, which variable will be same for all of them? Is theta same for them? You can see in the diagram, theta covered by A, theta covered by B and theta covered by C are different. Are their omega same? It is given in the question that their speeds are different and they are moving on the same circle. It means the radius of the circle will be same for the three particles, and if the speed is different then definitely their omega will be different. What can you say about the time? Should the time taken by these three particles should be same to reach this point or different? If they reach at different timestamps, they will not meet at all. It means these three particles should reach at this location D at the same time, and that is the point which will make a relation between these three particles. So here we can write theta A as omega A into T, theta B as omega B into T and theta C as omega C into T. You can see here I have not taken TA, TB, TC because as I said, time will remain same for the three particles. So now we just have to substitute the value of omega in terms of V and R. So here we can write VA by R into T. And velocity of particle A is given to us, that is 1. So that will be T by R. Similarly for theta B, we can write omega B into T as VB into T by R. And VB is given to us as 2.5. So 2.5 I can write as 5 by 2. So that will be 5T by 2R. And theta C will be VC into T by R. And velocity of particle C or speed of particle C is 2 meters per second. So that will be 2t by r. And now we have to find the ratio of distance traveled by B to C. So actually B will travel this distance, which is the arc of the circle, and C will travel this complete arc till here. Now we know that we can relate this arc length with the theta or the angle, and that relation is theta is equals to S by R, or S is equals to R theta. So from this relation we can write S of B as theta of B into R and S of C as theta of C into R. And as we know, we need to find the ratio here. So let's divide these two terms. So we have theta B with us. Theta B is 5t by 2r and theta C is 2t by r. So cancel the terms first. T and t will get cancelled out. R and r will be gone. So when you simplify this, this comes out to be 5 by 4. That will be 5 by 4. So let's check the options now. You can see here option B, 5 by 4, is the correct answer for this question.